Chapter 6, Section 6.2, Sum and Difference Formulas. There is one main objective in this section, using the sum and difference formulas for the cosine, the sine, and the tangent functions. The cosine of the difference of two angles is given by this long expression right here. So we have two angles that are different, alpha and beta. I will call them A and B. And the formula says the cosine of the difference of those two angles is equal to the cosine of the first angle multiplied by the cosine of the second angle added to the sine of the first angle multiplied by the sine of the second angle. In fact, there are sum and difference formulas for cosine of the sum, cosine of the difference of two angles, sine of the sum of two angles, and sine of the difference of two angles. Each one has its own expansion formula. Notice that in no way are we allowed to distribute sin through the parentheses or cos. The cos and sin are not algebraic objects, they are the name of the function. If we view these formulas backwards from the right to the left, then these are contraction formulas, and we will do an example of that as well. Let's start with an example for the sine of a sum. First example, find the exact value, sine of 5 pi over 12. Okay, we'll make this easy by noting that 5 pi over 12 is the sum of two angles. Not just the sum of any two angles, two known angles. So here we've got pi over 6 and pi over 4. We have our 30 degree and 45 degree angles respectively. And it's important because if these two angles are not known angles, then in the expansion we don't have exact values, and this would then be a calculator problem, and so using the identity may not be very useful. So the sine of 5 pi over 12, since 5 pi over 12 is the sum of pi over 6 and pi over 4, we identify this angle here to be A and this angle here to be B. We then use our formula, let's get that here, the sine of the sum is sine of the first angle times the cosine of the second added to the cosine of the first times the sine of the second. So first identify what is A and what is B. So here for us the A is pi over 6, the B is pi over 4. So we use the expansion formula, sine A cosine B plus cosine A sine B. Now we can either use our special right triangles to obtain the values, or if you know them, as coordinates of point P on the unit circle. Either way, sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2. Added to cosine of pi over 6, root 3 over 2, times the sine of pi over 4 is root 2 over 2. So multiply the tops here to get root 2. Multiply the bottoms, we get 4. Since this denominator is also 4, we can write the sum all over a common denominator. Root 3 times root 2 is root 6. So this represents the exact value of the sine of 5 pi over 12, where, notice, 5 pi over 12 is not a known angle. Yet, since we can represent the unknown angle as the sum of two known angles, this expansion formula allows us to calculate the exact value of the sine of the unknown angle. Okay. In addition to sum and difference formulas for sine and cosine, we also have sum and difference formulas for the tangent. So the tangent of the sum is equal to the tangent of the first angle plus the tangent of the second angle divided by 1 minus the tangent of the first angle multiplied by the tangent of the second angle. In a similar way, we also have the tangent of the difference of two angles. So you have to notice the signs here are not quite the same, the SIGNs, the plus and minus. You have to pay very particular attention to that. Let's go to the problems and combine this with the PowerPoint. We'll need our reference sheet here for our formulas, so we'll have that in the background. And here we'll have our first problem, and we'll work that through and proceed through the problem set. So problem 6.2. Problem 1. We know that cosine of 30 degrees is root 3 over 2. Use the formula for the cosine of the difference, so we need cosine of A minus B. Use the formula for the cosine of the difference of two angles to find the exact value of cosine 30. Okay, well, we don't need the cosine of the difference of two angles to do that. So we know right away, here in the background, cosine of 30 degrees, so this is known, and the cosine of 30 degrees is root 3 over 2. We're going to obtain that same value by using the identity for the cosine of the difference. So the cosine of the difference, let's get our formula. Here it is cosine of the first angle multiplied by cosine of the second angle. So that's cosine A multiplied by cosine B. And then our formula says plus sine of A times sine of B plus sine of A times sine of B. Okay. And we're also told in the problem that 30 degrees will be represented to be the difference of these two known angles, 90 minus 60. So we have cosine of 90 minus 60, which is still cosine of 30. So this is your A, and this is your B. So substituting these values in the identity, we obtain cosine 90 multiplied by cosine 60 plus the sine of 90 times the sine of 60. Okay. Now, be careful that the minus sign here is not represented here whatsoever, because the identity for cosine of the difference is this identity. So I am following any plus and minus signs that appear here in the identity, and I'm simply putting A where it calls for A and B where it calls for B. Now I'm going to work that out. So the cosine of 90 degrees, okay, so 90 degrees is right there. That's at pi over 2. That's at coordinate 0, 1. The cosine is the x-coordinate. So the cosine at 90 degrees, or pi over 2, is the x-coordinate, or 0. So this is 0 multiplied by the cosine of 60. I won't bother to get the cosine of 60 because we're multiplying that by 0, so this result will be 0 in the end, plus the sine of 90, so that's the y-coordinate at pi over 2, that's 1, times the sine of 60. And the sine of 60 is root 3 divided by 2. Okay, so we have 0 plus 1 times root 3 divided by 2, which, as you can see, works its way out to root 3 over 2, which we know was the right answer to begin with. So that was problem number 1. Okay, let's take a look at problem number 2. Problem number 2. Use the formula for the cosine of the difference of two angles to find the exact value of cosine 70 degrees multiplied by cosine 40 degrees plus the sine of 70 degrees times the sine of 40 degrees. Okay. Well, suppose the question just said simply evaluate. In other words, find the exact value of that expression. How would you know what to do with that? So what I would suggest is look at the pattern and observe the formulas that we have. So here are the formulas, and we need to find the pattern here. cosine, cosine, sine, sine, with a plus sign in between. So which one of these formulas then does it mimic? It mimics cosine, cosine, sine, sine, with a plus sign in between. Therefore, this is using cosine of A minus B. Now you can also look in the formula here, cosine A, cosine B. So this must be the A, this is the B, plus, the formula says, sine A, sine B. So again, see, this is the same A. A is 70 in both cases, and this is B. Okay, and by A and B, I mean 40 degrees is B, 70 degrees is A. So we compress this to be the cosine of A, 70 degrees, minus B, 40 degrees. 70 minus 40 is 30 degrees, which is a known angle, and the cosine of 30 degrees is root 3 over 2 as before. So that one's done. So that's problem number 2. Okay, let's take a look at problem number 3. Problem number 3 asks to verify an identity. And that identity, cosine A minus B, so this one's becoming familiar, divided by cosine A times cosine B, cosine A times cosine B, prove that that is equal to 1 plus the tangent of A multiplied by the tangent of B. Okay, so this is an identity. We have to prove the identity. So let's do that. Either work independently, left side only, or right side only, or both independently and show they're equal. I'll start with the left-hand side. So first we need the cosine A minus B identity, which we have had here many times. So the numerator is cosine A cosine B plus sine A sine B. So that is the expansion of the numerator. That is all divided by cosine of A multiplied by cosine of B. Okay, so that's the numerator rewritten and carrying the same denominator. Now what? Okay, it helps to keep an eye on where you're going here. I see a 1 and I see a tangent. Well, tangent, we know, tangent is sine over cosine. Okay, so notice here I have sines in the top and cosines on the bottom. I also have a plus sign, which thankfully I have here as well. I have a 1. 1 would represent division of the same quantity by itself. So I think what I see is I'm going to separate here. I'm going to separate the numerators into two fractions. So we'll have one fraction, cos A cos B, over that denominator. See, there's your 1, same quantity divided by itself. Then this piece, sine A sine B, divided by the same denominator. Okay. So this is 1. Now here, if you don't quite see it, we have multiplication here, top and bottom. You could literally separate this into two independent fractions that are multiplied together, like this. Right, so multiply bottoms, multiply tops, you're back up here again. And now you can see that we have exactly what we need. This is definition tangent A. This is by definition tangent B. And that is exactly what it was that we were asked to prove. So we've got the result there by working independently on the left side. Let's take a look at the next problem. Problem number 4. We are given that sine A equals 4/5 for a quadrant 2 angle A. Okay, stop. I would draw the picture right away. Very helpful. So here we are. We want quadrant 2 angle, so that's measured like that. And then here is our right triangle there. Now the information is sine A is 4/5. Well, the sine, we know, is opposite over hypotenuse. And we know that that is 4/5. So the opposite is 4, and the hypotenuse is 5. So 4 there, 5 there. By the Pythagorean theorem, this value here for x, this length of the side, is given by x squared plus 4 squared equals 5 squared. When you work this out, you get plus or minus 3. You get square root of 9. How do you know which quantity you want? You want to choose the minus because you are to the left of the y-axis and the x value there is negative. It doesn't mean the length of the side of the triangle is negative. It means that you are to the left of the y-axis and the length is 3. Okay, so this is angle A here. Okay. Then we have a separate picture that I'll draw for angle B. So here we have angle B. What do we know? Sine B is 1/2 for a quadrant 1 angle B. Okay, so quadrant 1, draw that there like that. There's our quadrant 1 right triangle. And we proceeded in the same way. Sine is opposite 1 over hypotenuse 2. By the Pythagorean theorem, this will give us square root of 3. And we choose the positive value because this is to the right of the y-axis. Okay, so that's for angle B. Okay, now what is it that we want? We want the exact value of, well, we have a number of things here to do. So first up, find the exact value of cosine A. Okay, so find cosine of A. Okay, that's this picture over here. This is for angle A. Cosine, we know, is adjacent divided by hypotenuse. And we have all that information provided right in the picture. The adjacent's negative 3, and the hypotenuse is 5. So negative 3/5 will be cosine of A. Okay. What else do we need to do? Second part of the problem, find the exact value of cosine of A plus B. Okay, so let's push this over here then. Cosine of A plus B, so we need the expansion identity for the sum. Okay, so let's get that in front of us. Cosine of A plus B, cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. Cosine A, cosine B minus sine A, sine B. Okay. So here's what we want. So what do we get? Well, we have all sides of the triangle known for A and B. So we just have to look at the picture to get that done. Cosine of A, well, we already computed it right there. We don't even need to look at the triangle. Negative 3/5 times the cosine of B, so that's this picture right here, adjacent over hypotenuse, so that's root 3 divided by 2, minus the sine of A. Okay, the sine of A, well, the sine of A we actually know here is 4/5. That was given, so 4/5 times the sine of B. Here's angle B, opposite over hypotenuse for sine, so that's 1/2. So those are all the quantities there. Now it's just an arithmetic problem. Negative 3 times root 3 divided by 10 minus 4 times 1 is 4 divided by 10. Compress this down to a single fraction, so we could write 4 minus 3 root 3. all divided by 10. I reversed this because this is negative and, oh, whoops, that's a mistake. They're both negative quantities right there. So let's do this again. Negative 3 root 3 minus 4 all over 10. Or if you wish, you could factor out a minus sign from the top and write 3 root 3 plus 4 all divided by 10 with a minus sign on the outside. So either way would be perfectly fine. Okay, let's see what's next. Find the exact value of sine A plus B. Okay, so now we need sine A plus B expansion formula. So let's put that here. Sine A plus B. Let's get that expansion formula here. Sine of the sum, sine, cosine, cosine, sine. So it alternates, sine, cosine, cosine, sine. And that's with a plus sign. Sine, cosine, cosine, sine. Okay, so sine A, cosine B, plus cosine A, sine B. So there's our expansion formula. So once again, we just refer to the known and calculated information, and if need be, we look at the picture to get the individual values. So sine of A, okay, that was given, that's 4/5. Cosine of B, do we know the cosine of B? Yes, we do. Cosine of B is root 3 over 2, or you could refer here, adjacent over hypotenuse, so that's root 3 over 2. Okay, plus the cosine of A. Cosine of A, here it is right in front of us, negative 3/5, times sine of B. Do we know the sine of B? Somewhere we got that here, right here. Sine of B is 1/2, or from the picture, we got opposite over hypotenuse. So that's a 1/2 right there. So we'll put that in, 1/2. Okay, so let's do out the arithmetic then. 4 root 3 over 10. I'll write a minus sign there, since we have negative 3 times 1. 3 over 10. Put that together as a single fraction. So that's 4 square root of 3 minus 3, all divided by 10. And there is sine of A plus B. Okay. Let's see what else we got. We have a new problem to do. So let's turn it like this. Verify the following identity. Okay. Now it doesn't say how. We could say simply by periodic property, directly tangent of x plus the period, which happens to be pi for the tangent function, is equal to tangent of x. And we have our period right here. So this is true by periodic property, so we could write in here true by, yeah, we already got the word by, true by periodic property, that tangent of x plus pi equals the tangent of x, as long as the p is the period, and it is. However, we could also use some formula for the tangent. So let's do that, since it's the nature of the section that we're dealing with. The sum formula for the tangent, here it is right here. Tangent of the sum. Okay, let's use that. Or, by sum formula, we've got tangent of x plus pi. Okay, so that's your A plus that's your B in your formula. So this will be equal to the tangent of A, that's x. Is that a plus sign? Yes. Plus the tangent of B. B is pi divided by 1 minus tangent of A, that's x, multiplied by the tangent of B, that's pi. Okay, so we got the sum formula right there. And let's get the tangent of pi. Okay, so let's put that right about here then. If you're at pi, which is right there, 180-degree rotation, you got negative 1, 0 on the unit circle, and that's x and y. Well, tangent of your angle is y over x. Okay, so 0 over negative 1 would be 0. Well, that's going to simplify our calculation to be tangent of x plus 0 divided by 1 minus tangent of x times 0. And that simplifies to just tangent of x. So whether you use the periodic property or the formula for the tangent of the sum of two angles, we end up with the same result, just tangent x. Okay, that concludes the problem set and PowerPoint for section 6.2.